All right, today's lesson will be on the midpoint theorem. We're going to prove that a segment joining the midpoints of two sides of a triangle is equal to half the length of the third side. Let's consider the triangle ACB. ED connects at the midpoints of AC and BC. So E is the midpoint of AC and D is the midpoint of CB. We want to show that this segment ED is half the length of AB. In order to do this, we're going to construct a parallelogram, but we have to establish it's a parallelogram. So we're going to extend ED. I'm going to put this point F out there, and I'm going to make D be the midpoint of EF. Therefore, ED is going to be congruent to DF, and we're going to connect F to B to establish FB. In order to prove that this is a parallelogram, I must show that these two triangles are congruent. Okay, so what I notice about this is that I have a pair of vertical angles. So these two angles are congruent. And remember, CD is equal to DB because in the beginning we said that ED was joining at the midpoint of this triangle. So if you look at this carefully, we have established side, angle, side, side, angle, side. That means triangle ECD is congruent to triangle BFD, which means that corresponding sides are in proportion and the angles are congruent. So I can now state this. Since we know this, I can say that EF, since corresponding angles are congruent, I know that this angle B, is congruent to angle C. And since corresponding angles are congruent, that means these two lines must be parallel. So EF is the same as AB. But since ED is half of EF, I can conclude that ED is also half of AB because EF is the same as AB. That concludes the lesson for today.